This video will be teaching you about series and parallel circuits in AC, done by Sandali Yaddehige. A quick background on what is AC. AC stands for alternating current, and as the name suggests, it alternates between positive and negative. The values of current and voltage changes with respect to time, and therefore it can be represented by a sine wave. Also, it can be represented in the form or a function of time where A is the max value and sine omega t where omega equals 2 pi f. Because of the alternating values of current and voltage, we use vectors instead of scalars. And for vectors, we have the polar form or else a complex number, which is also known as the rectangular form. Series circuit. So what is a series circuit? In a series circuit, the current flows in one path and all the components in the circuit therefore have the same current flowing through them. A parallel circuit. It's a closed circuit where the current can flow in two or more paths, and the current through different paths will be different depending on the resistance of each branch. So how do we analyze AC circuits? Many of the same rules of DC still apply for AC circuits as well, which is really good because now we don't have to remember a total of different formulas. Ohm's law, KVL, KCL, nodal analysis, and current and voltage divided rules still can be applied for AC. The only difference is that the current and voltage values are now represented in the form of vectors because they are changing with time. V equals IR. Now the R is replaced with impedance. We have three forms of series parallel circuits, RC, RL, and RCL, which is a combination of all three. To analyze an AC circuit, we can first replace each element in the circuit with its impedance. For a RLC circuit, the series connection of impedance can be found using this formula, where Z equals R, the reactance of the inductor minus the reactance of the capacitor. And the reactance can be found using these formulas for different frequencies. Let's take a look at this example. Now let's work through the example. First we convert our voltage to polar form and then take the total impedance and then convert our total impedance to the polar form, and then using Ohm's law we can calculate the current. Now our current will be in the polar form. And that's it. Hope you learned something from my video. Thank you for your time.